Scott Skelton, thanks for joining us here today. We're going to talk a little bit about all facets of sort of what you're seeing as this industry develops in Arkansas. But first, I want to talk about, your Arkansas roots, where you're coming from in this discussion, and how your background sort of shapes how you look at industrial development in rural Arkansas.
Yeah, certainly. Thanks, Lance, for having me. I am a born and raised Arkansan. I was born in Newport, an agriculture community. I was raised with a small group of neighbors and small churches, and just raised like a lot of Arkansans have been, with community mindset, and that having a strong community was always important to me. And also in my work experience, being in mostly industrial applications and manufacturing, it's quite a contrast to how I was raised. There is a unique balance, particularly when industry is brought into rural areas, and so it gives me quite a perspective, particularly with the Smackover formation and the advancement of the lithium industry.
Well, so you were at the Arkansas Lithium Innovation Summit last fall, second summit that we've had, huge attendance. You said one of the biggest challenges facing Arkansas's lithium industry isn't safety itself, but public perception. And we know how that can change things in the dynamic there. So what misconceptions are you encountering most frequently, and why do you think they persist in the popular imagination and conversation?
Well, it boils down to stigmatized words in industrial applications. For one, the term lithium has become linked to significant outcomes involving fires and, thermal runaway events. We see a lot of that on the news with car batteries. We see a lot of that with manufacturing facilities that were, burned down because of storage of lithium batteries. And so the term lithium has been somewhat associated with that outcome. We know in the case of direct liquid extraction that it's not about the batteries in that process. It is about taking lithium from the brine and bringing it up and preparing it for packaging to be used for battery manufacturing. So the term lithium does bring about optimism and hope, but it is also stigmatized with some things that are pretty visually upsetting. Secondly, the term mining also comes with stigma. And there are mines in certain parts of the country that have struggled with environmental impact. There are a lot of opposing views in terms of the necessity for coal mining and its impact to certain regions. And when we think of mining, it's often these open pits or these, large environmentally compromised areas in order to get a valuable resource. And so if a community member were to think about this in terms of open source mining or heavy mechanical mining, they may be disturbed and they may develop an opinion that this is going to affect their environment and affect their community.
There's the lithium extraction method here in Arkansas that companies are pioneering. It's called direct lithium extraction, DLE. And I think most of our audience knows what it is, but for our discussion purposes, let's frame it up. What exactly is DLE? How does it work? And what is its general environmental impact?
Well, as opposed to the other mining avenues, the brine contains lithium several hundreds, if not thousands of feet below the surface. And that brine is brought up to the surface, and then it's processed in containment. And that is significantly different from hard rock mining. Even though brine is associated with evaporative mining, there's no exposure of that product to large ponds or wide stretches of land. It's brought up from a drilled well or an existing well. It's pumped into manufacturing processes, and then it's contained until it's packaged and ready to be sent for use in other areas. But the importance of that distinction is that the industrial infrastructure around process safety management and control of hazardous material has advanced significantly, and they have gotten really good at keeping the things that need to be contained and keeping them operating efficiently, but also from impacting the workers and the public. And so direct lithium extraction is really an optimization of the advancements in innovation in oil and gas exploration. And it's great that we have that in the brine to where the disposition is where DLE is the right technology, but in terms of bringing it to the surface and manufacturing it, it has a very small footprint in terms of public impact, but it's also safer for the workforce.
Right. And so let's contrast that then with the footprint, say, of hard rock mining and also the evaporation ponds that you see in South America.
Certainly, the hard rock mining is one where they use mechanical force to extract lithium-laden minerals, and then that's sometimes open pits, sometimes it's deep mines, but heavy equipment, and there's a lot of travel, there's a lot of disruption to the Earth's surface. That material then has to be reduced down to something more concentrate, to where it can then be sent away for further processing. Evaporative ponds, those I think maybe 30,000 acres is required to do the work of what manufacturing can do in a couple of hundred acres.
Right.
And so the impact is real obvious and would be very striking for a resident or a community member to see their natural landscape go from pine trees and rolling hills to these wide open pits that are going to sit there for years in order to concentrate the lithium to where it's worth going then to get and to move on to further processing.
Those would not fly in South Arkansas.
That's right.
I don't think. So what is the case for DLE? Again, I mean, we've kind of said this, but as an alternative to those methods, sounds like smaller footprint, concentrating in a small spot, the activity that's taking place, and it's very contained, and there's not a lot of just environmental destruction.
That's right. And also, it is disruptive to handle minerals and stage them and store them and haul them, and so you have much lower dust, in terms of visible impact to the adjacent community. But you also have a efficient process that does not require a lot of alternative energy. It doesn't require a lot of alternative hazardous materials to process it. And so it's self-contained, it's efficient in and of itself, and very easy to advance in terms of innovation because it's in a parallel track with oil and gas and other liquid handling processes.
But from a toxicological and industrial hygiene standpoint, how different is lithium brine extraction from lithium battery manufacturing and battery storage? I think Arkansas would like to have some of that industry here to grow up around that. So what would those things, how would those be different?
Well, when you think about the threat or the risk of human exposure to a battery fire, that is mostly because the battery is really hot and it's causing the chemical composition to go from a docile contained liquid state to now a vaporized state or a fuming state. When you think about the manufacturing of batteries, the lithium and its electrolytes and the other minerals are still docile, and they're contained, and they're maintained by their infrastructure. They're maintained by good stewardship and process safety management practices. Certainly, more so is the lithium extraction process, to where there are hazardous materials required to process it, just like there are to manufacture batteries. But they're in their containers, and they're guarded by safety procedures. And so you have the ability to control exposure administratively through practices. And then if something were to happen that's unfortunate, those companies have response programs and response procedures they use that they can contain and control the impact of any unforeseen event. That balance between, is lithium safe? Well, it is a reactive, but it's stable. And that's an important distinction. You can have reactive materials that are unstable, whether they react to the air or water or what have you. But lithium is a stable material, even though it's reactive. And those manufacturing batteries and those extracting it from the liquid brine can do so without causing just a ubiquitous and continuous exposure to the workers or the public.
Well, what are then the real occupational health considerations in a brine-based DLE facility? How do those risks compare to conventional oil and gas? Stuff that we're already kind of familiar with in that region.
Certainly, from an occupational perspective, there are the general industry safety issues that they have to work through, like how not to harm yourself, how not to be hurt by the equipment or the process. But in terms of the lithium itself and the lithium brine, it is required to process it and treat it with caustics and acids. And so those are also stigmatized in some ways, but they're essential for purifying the lithium and getting it out of the brine. And then there's also solvents that are involved. But these materials are nothing new to industrial operators. They have good records and good experience with handling them safely, particularly if you think about this industry being a benefactor of oil and gas. And oil and gas has handled flammable liquids and combustible liquids that are also have some exposure concerns if uncontrolled. And so those who are operating in the lithium space have benefited from the process safety management and the equipment technology like API standards and so many other containment and control innovations that prevent those hazardous materials from being something that the workforce or the public interact with, unless it's most likely an accident or an emergency response.
Yeah. Well, Dr. Scott Skelton, who is the Principal Exposure Scientist at CTEH, thanks for joining us.
Certainly. Thank you.